Doing a recovery project for iPhotos for my wife, and I discovered these 3 shots of me driving the Mustang back from my brother's house after the kitchen remodel. Kind of cool. Welcome to Don's Manufactory. Well, today's project. I'm actually just going to take a piece of water pipe here and I'm going to machine it to take the place of the spindle. Anyway, that's my goal. I'm just going to see if it works. It'd be a pretty handy little tool to have for checking the alignment even before I put the front end together. I don't know, I'm not going to do this in time lapse. I'll just show you when I'm done. Update. Here is my tool and it's turned so that it fits right on there like that. That will let me check the geometry. And it will tell me the angle. I can check camber and caster. Just that easily. I get the camber and the caster set before I ever assemble the front end. Okay, back to work. Do you ever just tear stuff apart to see how it works? I decided to take the ball joints apart. See what makes them tick. Ball joint, how is it constructed? Well, pretty simply, we have an upper half which has this sort of narrow little band right here that is the spherical part that this ball runs on. The ball part of it is in 2 pieces. This is the upper half that has the grooves for the grease, and it just sits and runs inside that spherical part of the ball joint. Now, this was not a machined part. This is just stamped and then left to its own devices. In between the 2 halves of the spherical ball, we have a phenolic washer. So a little 1/2 inch shaft there that sticks up. So the whole thing sits together like that. Just like this. So it's free to rotate. And it actually does. If you manipulate the ball joint like this, you will see that this is actually spinning inside there, and that's to normalize the wear over the entire joint instead of having a wear pattern that just grooves in. When you assemble the ball joint, it's got that much play. Now you might say to yourself, wow, that's way too much. I got a sneaky suspicion that's the way it's built. They put this here spring and cup in there, and it goes right in the top half. So what that does is when the ball joint is unloaded, it's pushing it into the bottom half. With the weight of the car on it, it will collapse that spring and it'll be sitting in the upper half. But it makes me wonder, if I went and got a new ball joint, how much play would it actually have in it? If I put this in the vise with a brand new ball joint and then squeeze the stud down like that, how much play is there going to be in that ball joint? How much lateral movement can I get out of it? Hello, welcome to Don's Manufactory. So, today's update. I am still working on suspension geometry. The left side, driver's side, is still put together so that I can take measurements from it. The right side is all disassembled. So, here, I'll let you look over my shoulder and I'll show you the numbers that I've got so far. I just made up my own little paperwork here. These are templates for the Shelby drop or the Arning drop. 1 inch here, 1.25 inches here. I am going to go ahead and do the 1.25 inches. So, just some numbers that will make some sense here. Dropping the upper control arm 1.25 inches changes the angle of the ball joint by 5 degrees. The fear is that when the suspension is all the way at the top of its travel, that the ball joint will be at the end of its travel too, and you may break it, especially when there's a lot of steering and forces and whatnot going on. The ball joint from here to here is 74 degrees. Okay, now the swinging arm from the bottom of the shock travel to the top of the travel where the top of the control arm is hitting the snubber is just shy of 50 degrees. So that leaves 24 more degrees of travel on the ball joint than the swinging arm is moving. I measured this, and my ball joint is 16 degrees from the end of its travel when the control arm is up against the snubber. Now this is without the arning drop. This is just in stock configuration. So I checked my registration from the printer, and all of this stuff measures exactly what it is supposed to be. Center to center in reality on this paper is exactly what it is on the control arm. So this is an exact representation right here. I can just tape it to a piece of metal, center punch right on the crosshairs, and drill out the holes, drill the pilot holes, and I'll have my own drill plate. So I have a couple of those, just in case I bumped you, just in case I screwed up. Alright, so here's my next calculation. Now I want to have 4 degrees of caster, but I don't want the wheel to change positions. I want the wheelbase to stay the same. Okay, the distance between the spindle center line and the control arm, or the lower ball joint center pivot point right here, that is 2.5 inches. Okay, between this radius here, which is the ball joint, and the center line. Between this point here and this point up here, this is the upper ball joint pivot center line. Okay, that's 8 inches. So if I want to rotate 4 degrees and leave the center pivot exactly in the same place, that means the upper ball joint needs to move rearward on the car 0.558 inches. The lower ball joint has to move forward 0.172 inches. There's a couple of ways I can do this. I could weld the strut rod and then machine it back 172 thousandths. However, that unloads the strut rod bushing. I was thinking maybe what would be better is to have a 244 thousandths or 344 thousandths spacer. I could put it between the nut and the washer on the front side of the strut rod bushing and tighten them up by 344 thousandths, which would make the strut rod pull forward 172. Does that make sense? So my strut rod bushings would actually tighten up and be stiffer than they were, but not a hard spherical joint or something like that. So I would still have a smooth, quiet suspension, but I would have more stiffness, and it would pull the lower joint forward the needed amount, and it's completely reversible. So that's the plan that I have. You can see how if you were trying to get 4 degrees of caster by moving the lower control arm, I tried this last night without moving the lower control arm. I just measured how far the upper control arm have to go, and it's about 610 thousandths. So you have to move the wheel about 5/8 of an inch forward in order to get 4 degrees of caster out of just the lower control arm. So that doesn't make any sense to me, when even if you only move the upper control arm rearward the 600 thousandths in order to get your 4 degrees, you'd only be pulling the center of the wheel towards the rear of the car, maybe, you know, a couple hundred thousandths. So you can see how that's the better choice anyway. But, you know, I want to do it so that the wheel stays in the exact same spot, so I'll be doing both of these things. Those are my plans for the front suspension as of today. The next thing I got to do is get this stuff cleaned up. I'm tired of everything being so dang greasy and hard to handle. And I also have to make my arning drop plate and drill the holes so that when I get done with the control arm and I bolt it all back together, it is as it is going to be. So, if you have a suggestion for gloves, I just went through a pair of gloves in 15 minutes, which is pretty common. They just don't hold up very well. Gloves for mechanic work that can withstand the rigors. I go through, if I'm doing this kind of work here, I'll go through half a dozen pair in an afternoon. So if you have a suggestion, leave it in the comments. I would love to be able to get some gloves that actually work. Thanks. Okay, moving the camera here because I don't want to get sparks thrown at the lens, but hey, that happened anyway. Okay, what I'm doing here is cutting the control arms. My biggest worry about doing this is that my welding won't be good enough and the front end will fall apart on me. One of my main goals has been to create a database of the actual suspension geometry that other people can use when they're figuring out the problems with their car. I'm having trouble getting really solid empirical data that's repeatable. So stand by for all of the good numbers. They're coming, hopefully. So what I've got done so far is trimming this piece out. I had to cut the camera because I saw sparks heading towards the camera and I just didn't want to ruin my lens. Anyway, so there's the old position of the ball joint right there. And what I'm doing here, see, is I've got a plate. This is a 10 gauge, same as the arm. So I've cut it. I cut this tip here and I rolled it over, and then I cut this one, cut a wedge out of it and rolled that one in. And this little plate welds in like so. You can see, I don't know if you can see that or not, but I've got it marked for where the hole for the ball joint sticks up through. Basically, this is the lower plate, but at least you get an idea that's where it's going to be. So this goes up like so, be welded in place, and then the ball joint is a ½ an inch to the rear of the car. Okay, so progress is that the plate is finished, and I've got my little sleeve made for over here where the bolt, I'm going to have a longer bolt. Next job is to take this and cut the flat parts off here, leave these pieces here, so cut it along here and then around, along there and around, so that it can set on top of here. Define where I cut off the piece here just to clear the ball joint. Hi, welcome to Don's Manufactory. Well, today's update. I just finished fabricating the upper control arm. So I had to add a sleeve here. I moved, if you look at the control arm, you can see that the ball joint is now a ½ an inch to the rear of center. When I moved it over, I had to put a sleeve in right here, and I'll have to get a longer bolt for that. But that's what it looks like now. It just a little sort of an odd change. I mean, it kind of looks factory, but it kind of doesn't. So 8.2 degrees is the kingpin inclination. So I'm going to zero mine at that. Okay. So right now at this ride height, I have 0 camber. And you can see that as I raise the arm up, I get negative camber. 3.6 degrees worth of negative camber. And then when we shift it over this way, the car is sitting 5.5 degrees sloped because the front is on jack stands, the back is not. So if I wanted to make that, let me just do that. So if I make it 84.5 right there. No, come on, back. Okay, that's pretty close. Okay, so I am showing, let me get this. Okay, at ride height, I'm showing 3.3 degrees of positive caster. And when I sweep it up, because the camber is changing, so is the caster. So now I've got 5.4, and that's with the car sitting level, which it surely is not going to. I'm sure I'm going to have at least a 0.5 degree of rake, or maybe a whole degree of rake. So instead of 3.5, if the car is raked 1 degree low in the front, then I only have 2.5 degrees of caster instead of 3.5. But until I set the stance on the car, I can't adjust that stuff. So what I'll do is I will just get it ballparked so that I'm within a 1/10 of a degree left to right, and at the same ride height on both sides I'll have 0 camber, and I'll lock it down there. But then when I set the ride height, the stance on the car, obviously the front end stuff will change and I'll have to do something about it. But that is where I'm at so far. So you can see what it looks like. I cut this part off out of the middle there, and I made another plate and welded it in. And just a few data points. This flat section right here that normally, you know, sticks out on the control arm, in this configuration with the Shelby drop, and that's 1.25 inch Shelby drop, this plate here has to have 12 more degrees of angle to it than this flat top surface on the control arm. If those two things are true, then I have 10 degrees of leftover or additional travel on the ball joint at the top, and well, actually I have 10 degrees at the bottom and about 12.5 degrees at the top. So I didn't quite hit it dead center. I may have only been at 11.5 degrees or something here by the time I got it all welded. But that's the design of the thing. Now the only worry I have is when the wheel turns this way, am I going to contact the control arm over here? Thanks for watching today's update. Later.